in number 5, we're asked to figure out if we have 3 points lying on a plane, how far is it from this plane to another point? So let's say it's my plane, all 3 of those points lie on it. I got my other point up here somewhere. Well, if I can figure out the equation of this plane, which I can do using 2 vectors, then I'll have a definition for it, and I can always find the distance between a plane and a point. So I need some directions. So let's start with AB. AB, using vector subtraction, will give us -4, -3, and -1. If I do AC, you can also do BC, nothing wrong with that. I'll get 12, 2, and -4. Now for my Cartesian, I need the normal. I need AB cross AC. So let's do that. AB, -3, -1, -4, -3, 2, -4, 12, 2. And you could have used the scalar multiple on the first one or the second one if you want to make them all positives or smaller numbers. That's totally fine. So 12 minus -2. I'll get -12 minus 16. I'll get -8 minus -24. Okay, so I end up with a I end up with an equation of 14, -28, and 16. Sorry guys, no typo there, got distracted for a second. Last number was wrong there, right? It should be -8 minus -36. That would be better, which gives us 28. Yeah, there's nothing wrong with that vector. I'm just going to simplify and make our life easier. Divide it all by 14. I get 1, -2, and 2. Just a nice, easier scalar multiple to work with. So using that, we can make our Cartesian now. So we get x minus 2y plus 2z plus d equals 0. I can use any of the points, a, b, or c, to figure out my value of d. I'm going to use a because it's the nicest numbers. So I'll get 1 minus 2 times 2 plus 2 times 3 plus d equals 0. So on top, I get d equals -3. So I have myself a Cartesian, x minus 2y plus 2z minus 3 makes 0. Now I can do distance. My distance uses my Cartesian, the magnitude, which I absolute of, and point P. So 1, -1, 1. I can write that down over here. P is 1, -1, 1. So I've got 1 minus 2 times -1, z, 2 times 1 minus 3, all over our normal magnitude, 1 squared plus -2 squared plus 2 squared. Gives us a total on the top of 1 plus 2 plus 2 minus 1. In other words, 2. On the bottom, we get the square root of 9, which is just 3. So the distance between that point and that plane is 2/3. And these are just units, right?